Hello everyone, and welcome to this latest webinar from IHS Markit titled Moving Forward with Open Optical Networks. The pressure is on for the industry to deliver more open and interoperable optical networks. But are network operators ready and willing to trade off performance for openness? So today our panel will explore more about the opportunities and challenges that lie ahead. Our webinar is co-presented by IHS Markit and our partners ECI Telecom and Fujitsu Network Communications. My name is Alan Tatara, Event Manager for the IHS Markit Technology Group webinar team, and I want to thank everyone for joining us. So before we get started, I want to highlight just a few features that are available for you on our webinar today. So the console that you're looking at is completely customizable. So you can open, close, move, or even resize any of the windows that you have open on your screen and arrange the console as you wish. Now, in your console, there are a number of application widgets, and these contain additional features that are available for you. I do want to mention the resource list widget, and this is where you're going to find additional material about today's topic, including the downloadable slide deck session, as well as other valuable resources, including a special report authored by our own analyst, Heidi Adams. And all these materials can be accessed and downloaded right from your console. And we do want to make this an interactive session, so we've included a Twitter widget. You'll see that at the bottom of your screen. This means you'll be able to tweet directly from the console. And today we're using the hashtag Optical Networks. We will also have a live Q&A session directly after the presentation, so please submit your questions or comments at any time by using that Q&A box that's on the left side of your screen. And if you encounter any technical issues during the webinar, just click on that question mark widget and you will receive the answers that you need. So now let me introduce our panel. First leading our discussion is Heidi Adams. Heidi is Senior Research Director in the Transport Networks segment at IHS Markit. Also joining us is Dr. Scott Wilkinson. Scott is Senior Director of Portfolio Marketing at ECI Telecom. And rounding out our panel, we have Joe Masarino. Joe is a Principal Solutions Architect in Optical Networking at Fujitsu Network Communications. So welcome to all of our speakers. It's great to have you with us today. So let's get started with our presentation. So Heidi, I'll turn it over to you.
All right, thank you, Alan, and welcome to the audience. Our key objective for today, as Alan mentioned, is to give you a view as to where we are today with respect to moving forward towards open optical networks. So for our agenda today, we'll start with putting in place a baseline definition of what an open optical network is, and we'll have a look at some of the related market trends and market data. We'll then have a look at some of the industry problems and challenges that can be addressed by moving in this direction, and we'll explore some of the new options and solutions associated with open optical networks. From there, we're going to have a closer look at some of the work that has been done to date in the deployment example section. And finally, without a doubt, there's going to be a lot of work ahead before we see mass adoption of open optical networks. So in our next steps section, we'll have a look at some of those areas that are going to be tackled next. As we go through our presentation today, there will be a couple of opportunities where we're going to ask you to provide your input into the session. And of course, at the end, we'll have a Q&A session. And for this, I encourage you to enter any questions you may have as we go through the presentation today. Pop those into the Q&A interface, and we'll have a look at that during our audience Q&A session at the end. Oops. So with that, let's get started. And to properly frame our discussion today, we're going to spend a minute just defining what we consider to be an open optical network. Oftentimes, you hear the terms open line systems, optical disaggregation, optical white boxes. There are several things being thrown in the mix. And yes, there is a relationship between these terms, but on an individual basis, they don't all necessarily capture the full picture. So let's put that picture together. If you look at an optical network at its simplest, you know, the two box plus an arrow view. Optical networks consist of data plane equipment or hardware, as you see in the bottom of this diagram, and generally that includes the line systems, ROTMs, amplifiers, etc., and the terminal systems or transponders. Above that, in the software box, we have our management and control software. This, of course, can include element network management. It also today includes SDN control and moving forward analytics, and other applications that are generally abstracted from the hardware level. To link the two, we have APIs, northbound and southbound, so basically a mechanism to pull stuff out of the network that we can then do analytics and other activities and applications on, and then southbound APIs, which enable us to direct and communicate towards the hardware and get that to do what we need it to do within the network. One thing you might say, hey, what about the software, the operating system, that base stuff that generally is associated with the hardware? Just for argument's sake, today we're going to put that in the hardware box, and we'll discuss in a moment what the implications of that with respect to how hardware is also evolving moving forward. So if I look at openness, you can apply openness to each one of these three layers. On the software side, open, I think, is fairly well understood within the industry. It's broadly applied, especially on the IT side. So open source software, generally developed by contributions from a community of interest, generally freely available to anyone who's interested. And of course, there is also a commercial aspect to this. Oftentimes, you will see snapshots of open code that is curated, that is supported, that is made available to customers as part of a licensed distribution. If I look at optical networks and some examples of what open source software would be in that domain, I've got ONOS, OpenConfig as examples. There are also many more. If I look at the API section, openness and APIs considered much in the same way as what we see for software. So there are many of them today in the industry. Lots are being worked on. The OIF's Transport API or TAPI is an example. We have REST APIs. And then also an important part of this is, how are you modeling network hardware and then how are you interacting with that? So netconf is also frequently mentioned in this context and is increasingly becoming the de facto go-to mechanism for communicating with optical equipment. Another aspect just to mention is we move towards streaming telemetry, so grabbing information out of that hardware layer, getting access to network information. We also see gRPC cited in that context. Finally, the hardware side. There's a lot of interesting things going on in this area as well. Two groups that we've all heard much about. You've got AT&T's Open Rotom MSA activity, and you've got the Telecom Infra Project, or TIP. They're doing a lot of work in this area as well. So within open hardware, a couple of different things that we see. There are, examples of reference designs that are made available to the world to go and build, and the TIP's Voyager project is an example of this. There's also baseline specifications for building open interoperable hardware, and I'd argue AT&T's Open Rotom is more along those lines. But there's also a third component, which is basically what I would call standard optical transport equipment, equipped with open API support that enables it to be managed and controlled by any vendor's SDN and or orchestration system. So that also fits that open hardware description. So if I sum that whole thing up, fundamentally, open optical networks being defined as open hardware supporting open APIs that can interact with and be managed by open software. Okay, so that's the context for our discussion today. I did want to have a quick word with respect to hardware disaggregation, because oftentimes disaggregation is equated with openness in optical networks. So if you take the hardware box from that previous slide, and you see what I've done in blue here is kind of blown that out a little bit. Fundamentally, disaggregation in the optical context is the decomposition of the optical system into its elemental parts. In the case of optical networking equipment, we generally look at line systems and transponders, and you could even take it one step further and disaggregate that base hardware operating system or software that I mentioned on that last slide as well. If you did do this, and say you did this in a line system, for example, to me that's analogous to having, a bare metal optical system. And there's some examples of this in industry. Lumentum has an Open Rotom system that's going down that path. The word optical white box also would fit into here as well, and I think that is a standard design where you then import your own software. So we do hear those terms in this context. So just a little bit of a mention or a thought as well. As you look at disaggregating, there also remains this issue of interoperability. It's very critical here. So between the transponders and the line systems, there's many mechanisms and aspects, and we're going to explore today a little bit of the work that's been done in terms of making this all work. So key takeaway on this slide, Open can include disaggregation, but disaggregation is not required fundamentally as part of the definition of overall open optical networks. All right, so let's move on to a little bit of the market data, give us a little perspective of where we're at. So for this, I'd like to share some results from a service provider survey that IHS Markit conducted last fall. So the focus on that survey was on open line systems in particular, but we're hearing a lot of the same themes being echoed when we ask about the broader case of open optical networks. So I thought it was relevant to share some of the data in this context. So if you look at what are the key drivers for open line systems, the number one is to reduce reliance on a single vendor. Less CapEx, better performance, being able to select best-of-breed systems. These also came up as being important things to over half our respondents. Key takeaway, through moving to open optical, and by definition moving towards more interoperability, plug-and-play capabilities, service providers are hoping to gain more flexibility in vendor selection and that ability to adopt new technology as it becomes available in a quick fashion. So also in that same survey we pinged for, are you ready to move towards open line systems? And the feedback that came back was interesting. 6% considered they'd already deployed. And into this category, if you're familiar with subsea systems, open line systems is not an uncommon mechanism today, and we're seeing upgrades of transponders that are independent of that line system, so it fits the definition. By 2018, 30% say they're looking at this seriously and considering deploying some aspect, but there's still well over a third that don't have a clue. So they're either not committed or they just don't have enough information. So key takeaway here, early days for open optical networks. All right, so with that, I want to check the audience is still awake, and I'd like to ping a question to you. So that last survey was on open line systems. I'm curious what you think with respect to this broader definition of open optical. Would you consider deploying all of or some aspect of open optical within your network? Choices, you've already deployed, or you plan to do it this year, or 2018, maybe 2019 or later. Other options are, nope, not going down this direction, or maybe you don't know. So I'll just give you a couple more seconds to click. All right, here we go. Let's see what the answers are. Very interesting and quite consistent with that last slide. So what jumps out at the very bottom, 30% of you aren't sure, and that's probably why you're on this webinar today. Another 22% are not planning to deploy, but probably want to hear a little bit more about it. And then the balance, so we have half the audience is seriously considering this. They've either already deployed or are moving down that path. So you're in the right place. We're going to share a little bit more information with you today. So with that, I'm going to move over and let's have a look at the problems and challenges being addressed at Fujitsu. Joe?
Well, thank you, Heidi. In today's market of closed platforms, there presents various challenges to the service providers, resulting in competitive disadvantages. Service providers are dependent on one or two vendors for all or parts of their network, since they are designed to only operate within their own ecosystem, presenting risk and slow service deployment. A disaggregated system presents greater scalability and choice for best-of-breed network functionality, offering a smooth pay-as-you-grow evolution. Conversely, a multifunctional converged platform, the traditional platforms that we see out there, limits scaling through dependence to the chassis and backplane, requiring a large footprint, a large power and thermal reserve, when initially just using a few of the chassis slots. Operational inefficiencies occur when many manual provisioning functions are needed to turn up a service. Open APIs enable automation of these processes, reducing or eliminating these operational inefficiencies. And an often made analogy of innovation and speed to market is that of the PC industry, and this is one I like to use. Once this technology was open, designers quickly advanced functionality of chipsets, complete functional boards, and software. And a similar functional advancement and service velocity can be applied to open optical networking through the establishment of these open design guidelines. Let me turn this over to Scott for his view.
Yeah, I'm just going to build a little bit on what Joe said there. I think he made some very strong points, and I'm going to follow up with why would you deploy an optical network? If we saw from the poll, there are some people who say they would never do it. There's some who don't know, and that's what we're trying to get into here. Why would you actually do that? So building on what Joe said, the typical network today, you have vendor lock-in. Once you choose a vendor, you have a 5 or 10-year contract. You've decided to go with their management system, their interoperability. You make everything work together. And the promise of open optical networks is that we're finally going to get away from that. We all remember probably the days of Sonnet when Sonnet was standardized and everything was going to work together, and then we actually tried to do it and found that the reality wasn't quite there, especially at the management level when you got to more complex things. The idea of an open optical network is the optical network now moves away from vendor lock-in to true full interoperability, not just at the data layer, but all the way up through the management. And now that you have an open optical network, you can do these other things that Joe touched on too, which is moving away from manual operations. More and more, we're seeing networks getting increasingly complex and fewer people available to work on them, especially with the smaller vendors, smaller network operators. With open optical networks, with these open APIs that are standardized across multiple different vendors, so you've moved away from vendor lock-in and now you have a standard way of talking to them, you can more and more do network function automation. So you can now automate operations like turning up and turning down and monitoring and all the other things that you do with your optical network across the entire network and moving away from manual. Also, another aspect of vendor lock-in is moving away from the idea of limited selection. If you pick a particular vendor, you're stuck with whatever they have decided is the priority, and that may or may not be the best thing out there. With an open optical network, you have the ability to say, I like what this particular vendor is doing with their packet optical system perhaps, but I really like what someone else is doing with their ROTMs. And this way, you're able to have an open and guaranteed interoperable solution with common management that allows you to pick the best of breed, which is really where we want to get to with open optical networking. And finally, the kind of goal at the end is this idea of service level control. And we use the term service level control to avoid saying SDN on every slide. But the idea here is that now you have applications running on top of your network that the network understands the application as opposed to just the service. With open APIs and open optical, that's where we're going to, and that's where we hope to get.
All right, thank you, Scott. So for this next section, we're going to have a look at some of the new options and solutions being worked on. So I'm going to stay with Scott, handing back over to you.
Sure. So the real key, and I think you've heard this from what we've been talking about, to all of this open optical networking is we've got to certainly get the physical layer interoperable. That's critical. You've got to have that happening. But the key is to make sure that the operations is interoperable. That's where all the real power comes from. And on the optical network, that comes from something called optical domain controllers. You've seen the slides before, I'm sure, about SDN. They always show a big orchestrator on top with all the applications talking into it. The industry has moved to this idea that the optical domain controller will probably be separate from the packet domain controller, at least for the time being, and perhaps forever. We don't know yet. But that's because there's so much going on at the optical layer, and so much of it is vendor-specific or application-specific, that these optical domain controllers are being developed. And whether it's an aggregated solution or a disaggregated solution, whether it's packet optical or open line, doesn't really matter once you've got an optical domain controller in there, because that is supposed to abstract that optical away. And that allows the orchestrator on top now to have an intent control down, which means, for example, it knows you need to put a packet system up solution up across a network, it knows what the pool of resources look like. It abstracts that all away and makes it easy to work. The best way to get there is through Open Optical Networks, because now you've standardized those APIs, you've guaranteed the interoperability, and that gives us that solution we're looking for. So to go into a little bit more detail on what you can do with that, the building blocks that you've got to have underneath it, you're moving away from the traditional point-to-point, single vendor type of solution to something much more open, where the network now has got to have multiple vendors. If someone is telling you they have an SDN or an open optical solution that only works with their equipment, they're violating the terms of the agreement. In order for it to be open, in order for it to be truly software defined, it's got to be multiple vendors. And that means multiple layer restoration as well, and restoration across vendors. If you remember in the past when we put SONET together and we had terms like BLSR, and we could very rarely get those to work across vendors, with Open Optical Networks, that's where we're going to go. And being able to understand not just restoration perhaps at the wavelength layer, but at the OTN layer and the transport layers on top of that. All of them are going to be viewed holistically. That's where we'd like to get, so that we can have very smart network provisioning, smart network maintenance, and intent-driven provisioning of the network. So the components there are things that you're familiar with. Most of these already exist, which is good news. Programmable transponders, programmable ROTMs, OTN switching, packet optical systems. All of those can be part of an open optical solution. And the good news is a lot of them already exist. So Joe, I'll hand it to you for a little bit more in depth on this.
Thank you, Scott. So as mentioned earlier, there is no one open optical design. There are degrees of openness, as shown in this illustration, where vendors can interoperate at various levels, and I'm showing from the left side to the right side. Starting on that left side, the Open Rotom MSA, where you have an interoperability between vendors. Fujitsu has been deeply involved in this as a selected vendor for the Open Rotom transponder and SDN controller design. The Open Rotom MSA integrated multiple vendors, components, and this mix of vendors initially addressed a set of requirements focused on the metro optical interoperability. This enables any vendor's transponder, ROTM, or optical pluggables, SDN controller to interoperate with one another vendor's element, eliminating that vendor lock-in mentioned several times now, while expediting service delivery. However, the degrees of openness varies when performance requires operation outside the metro space. And that's where we move to the right one notch to paired ROTM application. In that paired ROTM application, we maintain different vendor transponders, so maintaining that openness between the two, but require the ROTMs at each end of the network come from the same vendor. And this is to enable control loops that provide automation for optimizing the ROTM segment. The paired transponder model has open ROTM, but requires bookended transponders, so sort of the opposite of what I just went through with the paired ROTM. The paired transponder matches transponders from the same vendor. This will enable specific functionality such as an SDFEC, which is proprietary to each vendor, but offers a greater reach performance beyond those metro specifications that were originally laid out in the Open Rotom MSA. A sweet spot for open operation with optimal performance is the paired transport module or model, using the same vendor for each of the two segments of transport. So the same vendor for transponders and the same vendor for the ROTMs, but using different vendors to still interoperate the transponders with the ROTMs. This enables a greater reach and automation operation, reducing OpEx. And finally, the proprietary transport provides a further level of automation and optimization of the wavelength service while still offering open APIs and pluggable optics. All of these models have levels of openness, and APIs and pluggable optics are consistent throughout. And scaling from one model to another using software licensing allows the service provider to flexibly minimize vendors while still offering best-of-breed operation in a pay-as-you-grow model.
All right. Thank you, Joe. Yes. So for the next section, we're going to move into, we've just seen some overarching how it all hangs together. We're going to move into some more real-life deployment applications and real-life projects that are being undertaken under this banner of Open Optical Networks. So Joe, starting with you to share some of your experiences here.
Well, great. And thanks, Heidi. In this alien wavelength use case, and we've seen this many times before, but by varying parts of the network, they can be easily achieved for a more advanced functional performance using disaggregated network elements. In this case, the paired transport that I just reviewed in the last slide that had various illustrations is an example of a best-of-breed transponder and a best-of-breed ROTM paired together from different vendors. A customer of ours wanted to break away from their original ROTM vendor and migrate to a more advanced technology offering 200G transport operation, SDN control, and management without incurring a complete replacement expense of removing the entire ROTM system. Using a beyond 100G transponder from Fujitsu with their existing ROTM network, we solved the functional issue offering 200G transport and greater reach performance. The transponder and ROTM still have the open optics, APIs, and interoperation, but the disaggregated transponder provided a 16 QAM modulation with STFEC and NetCopying interface, and this set of functionality enabled the greater capacity in operation at 200G, greater reach performance, SDN control and management, to a legacy ROTM network offering a cost-effective solution to their functional requirements. Here's another example using the Open ROTM use case, and this was where Fujitsu was one of the select vendors in the Open ROTM MSA use case, and the Open ROTM MSA integrated network components from multiple vendors that included mainly ROTMs, transponders, and the SDN controller. We have completed trials of this use case and are going to a first office application by the end of the year. The phase one operation included a metro reach set of requirements that was within the 500-kilometer range, a 96-channel flex grid, 100G service creation, enhanced FEC, which is a standard forward error correction used, also modulations using DP-QPSK. Where we're going with this is there is a second phase that is being looked at and being modeled, and that will have flex grid modeling, a longer reach using ILAs, regens, and also looking into interoperability between proprietary SDFECs, making that a standard between vendors going forward. So several things to be looking forward to that accelerate the pace of innovation and competition and increase the volumes through mass adoption. Let me turn this over to Scott for his views on this.
Yeah, I want to build on what Joe was talking about and talk a little bit about where we can go now that we've gotten that. And I specifically put this slide in here based on some of our experience, but mainly because it's very rare and kind of odd to see the words open and encryption on the same slide. Typically, you think of encryption meaning something has to be controlled, something has to be very closed. But now that we're moving to these open optical networks, as we've described throughout this webinar, and we have these open APIs, and we've guaranteed these kind of interoperability, we can start looking at what applications now can go on top of that and expanding beyond just making the light work over the equipment. And optical encryption is one that we've been very involved in. And the idea is that some service providers want that to be a completely closed environment. Some of them want their enterprise to run it. Some of them want to run it through their orchestrator. And through open APIs, you can do this even with encryption. You can have an open Yang model that includes things like the encryption key exchange and how that works. All that can be programmed through some sort of external device, whether that's your ITMN, whether you have the devices do it, whether you're buying some sort of solution from someone else, whether you're allowing your customer to do it. But because we've moved to open, because we've moved to standard APIs, these kind of applications are coming. And I think what we're learning, and I think Heidi said this right at the beginning, we're very, very early in this process. And once we have these open APIs and the interoperability and the ability to plug and play and put in best of breed, we're going to come up with all sorts of new ways of doing things with these networks that we haven't thought of today. And that's what's really exciting about open optical networking.
All right. Thank you, Scott and Joe. So for this next section, we're going to take a look forward. So, we've heard a little bit about, again, definition and framework and key elements of an open optical network. We've also heard a little bit about some specific use cases and projects and directions under this banner. But that's, as Scott has said and Joe has touched on as well, there's a lot of work ahead. So in this next section, let's have a look at some of the next steps. And I'll start with Joe for a view on where we're at with Open Rotom.
Great, thanks, Heidi. Well, just to set the baseline for Open Rotom, the objectives here were fast service delivery and increased pace of innovation, greater supplier independence, and lower costs through vendor interoperability. I would say through Fujitsu's participation in this project, those objectives were achieved. There was Open Rotom standard for the Metro application, and probably most importantly, that benefited everyone involved, the equipment vendors, the multiple equipment vendors, and the service providers, is the dramatic improvement of specification time through discussions between one another, very close discussions between one another in terms of interoperation, functionality desired, the end goal, and while still meeting the end goals of turning up a new service very quickly. Also, in terms of some next steps that are occurring here, the first office application is being targeted for the end of this year. So we've completed the original field trial for the Metro application and going into first office application the end of this year. The inclusion into the next set of functionality will include amplifiers, ILAs for extension into long-haul applications, and then also improving or scaling the capacity of the clients. The original Open Rotom trials and first office application was just for 100G applications, but we're now looking at the next layer of functionality, including 1G, 10G clients, also OTN multiplexing. Scott?
Great. So I'm really excited, and most of us are pretty excited about what's happening with Open Rotom. The problem is it's just one of many that are happening. And if you've been to any of the trade shows and the talks this year, you'll see this topic coming up again and again, that there are so many different solutions out there right now. They're all well-intentioned. They're all leading to where we want to go, but we're a little concerned that there's so many of them. And this comes up again and again with discussions in the industry. The big concern is that we move from where we were in the past, where maybe a dozen different vendors came up with proprietary implementations, and the carriers forced certain interoperability solutions to work. So maybe you had a dozen different groups, different interoperability things that had to work out. The point where we are now, where there's a lot of different solutions out there, each carrier has their own little twist on it. They're picking one of the many groups, and they're adding things to it, and they're building around it because they don't think it's moving fast enough. And now they're pushing that back down to the vendors. And instead of having, in the past, the carriers getting a couple of different vendors working together, we're very, very worried that we're going to get to the point where we have hundreds of carriers with proprietary implementations asking the vendors to meet them. And there has been this phrase going around the industry of, if we get too open, we get proprietary, and we certainly don't want that to happen. So again, going back to what Heidi said at the beginning, we're very, very early in this. The industry in general understands we've got to come to some sort of converged and consolidated solution. If we don't, there's this worry that we're going to have to go back to some sort of traditional standards process where some group is just going to have to step in and say, okay, this openness stuff was great, but it's not worth it. Let's go back to something standardized. Nobody really wants that to happen. We know standards are really too slow. So there is a lot of talk about where do we go. One of the solutions that's proposed is that perhaps we will find some way to come up with a core set of properties for open optical networking that everyone's going to agree on, and then just a little pieces around the outside, maybe. That's where we start putting the proprietary implementations as we slowly work to involve those and get them in. Again, what we should, one of the points we wanted to make in this webinar is, don't judge open optical networks by the way they look today. We're moving very, very quickly, which is what we all wanted. We're moving towards a future which is much, much brighter, which will allow us to do much greater things. We just have a few little hurdles to get over to get there.
All right, thank you, Scott. So at this point, that would be really interesting to ping the audience and see, what do you consider to be the main obstacles ahead on this path towards open optical networks? Where do you see the priorities in terms of, what we need to be addressing? So you've got a few choices here. You can select all the ones that apply in your mind. So the first one being open, not currently well defined enough by the industry. Okay, number one. Second one, too many open groups and projects to choose from. So a little bit towards what Scott was indicating just a second ago. Third challenge could be perhaps as an operator you're not willing to take the trade-off in terms of reduced performance in exchange for more openness. So this is something we hear potentially a little bit on the long haul side in terms of specific applications. Fourth one, prefer simplicity of pre-integrated. Maybe you prefer to have a single vendor in your system, and this openness, isn't really for you. And then, of course, the last one, you don't see any major challenges ahead. Off we go. So let's see what our audience responds with. All right, we have a little bit of a mix. All right, so first and foremost, open not well defined by the industry. Well, hopefully today we're putting in place a couple of definitions to start measuring this by, but definitely a key concern that we all be on the same page in terms of what we're discussing when we do talk to open optical networks. Second key one here, actually almost tied for second at 41% each. Too many groups to choose from, and yes, certainly that. We're hearing a lot of that in industry conferences. And I think, there is a view over time that there'll be a process of natural selection, and we're already starting to see some of the groups start to merge. So, if we have 10 or 12 different organizations today, that should come, down to a more manageable size. So we'll have to see how that progresses, or potentially, as Scott indicates, maybe we do need to go back to standards. I think standards don't go away. They will be back in here. It's just a matter of what the role is versus what we're seeing in all the open MSAs and various organizations. That last one, performance. in exchange for openness, that trade-off, probably the next question to ask is per application. Through other informal surveys we've been hearing, it really depends on where. Maybe in the metro you're more flexible, maybe in long haul you need every last little bit of spectrum used as well as possible. So maybe a little nuance there. And then some prefer simplicity of pre-integrated. The Apple model will survive in some ways. And then finally, very few of you see no major obstacles ahead. I find that quite interesting. Okay, so with that, let's move into our last section. So just a couple words from each of our sponsors to indicate within their portfolios how they're helping to move the industry towards open optical networking. So starting with Joe, I'll hand over to you.
Great, thank you, Heidi. Fujitsu has a family of modular software and hardware platforms to address open optical networks, and through the blending of our Ventura SDN control and management software platform and the Onefinity programmable disaggregated platform, Fujitsu offers a flexible lifecycle service orchestration for optical networking. The Ventura system offers multi-layer SDN control and management for high-value applications, network virtualization to lower cost, expedite service delivery, and network analytics to troubleshoot, optimize performance throughout the entire network. And this is across multiple vendors, not just Fujitsu equipment, but multiple vendors, as this is all standardized through the open NetConf Yang, open API interfaces. The Fujitsu Onefinity hardware platform drives SDN through a disaggregated programmable architecture. This architecture consists of modular functional blades that are optimized for different parts of the network: transport, packet, open line systems. In the transport, there's also subcategories to optimize in DCI for data center interconnect applications, and other areas of transport, including metro and long-haul transport. In the packet area, there is modular operation with a 1RU platform that is still modular and operates from a 1 gigabit Ethernet to 100 gigabit Ethernet with a digital wrapper option for direct connect to the open line system or Rotom system. And then the Rotom system in itself consists of a family of units extending from a fully open based as defined by the Open Rotom MSA, addressing the metro applications, to more higher performance versions that will optimize performance through interoperation, either with another vendor's Rotom or paired with Fujitsu Rotoms. And finally, the Fujitsu offering is all pulled together through our services group that can design, integrate, and deploy a network along with ongoing management going forward. Scott?
Sure. So ECI, for those of you who aren't familiar with it, ECI is a company that's been around for 50 years. And we do everything from the hardware at the core of the network, the metro and the edge. We do packet, we do optical. We do the management systems around those. We do applications. So the SDN revolution, where you started putting applications on top of management, we do those as well. And we also do a rather innovative security solution that's built around all of it. And we won some awards on that recently. In fact, last week in Nice at the INGON conference, we won the Best Test and Measurement Award, which is kind of an interesting one because all of our test and measurement is built into our hardware. It's all part of this idea of having more intelligent networks, more intelligent equipment, giving you more insight into what's happening to allow you to do things. But what I wanted to particularly highlight here is light control or optical domain controller, which we've just started talking about. And you heard earlier in this webinar about what an optical domain controller can do. Light control is ours. It does work, in our belief, it should work at the WDM layer, the OTN layer, and even at the packet layer when you're doing packet layer transport. We've built it to be open based on open source type software, the input from the community, and we built it on a modern microservices platform, so it is sort of the latest and greatest. And this just is the first part of our entire light control SDN solution, which specifically is targeting the optical, which is what we're talking about here today. So it seemed appropriate.
All right, thank you, gentlemen. So with that, I'm just going to wrap up our session here. And just a reminder to you online, please, if you have any questions, feel free to enter them into the console at the bottom of your screen. We'd love to hear from you and hear what your concerns are or any questions you have for our panelists. So let's wrap up a couple of the key takeaways and conclusions for our session today. So first off, I'm hoping you will have heard fairly clearly that there is a role and there is demand to move towards more open, more interoperable optical networking, with the key desires here is to drive more flexibility and agility into the network, into components within that network, and also into the vendors that you can place within that network. Second key takeaway here is, I think as an industry, we're starting to move towards a common vision of the key building blocks that are required and the work that needs to be done to define the open interfaces, to define what it means to be open hardware, to define what it means to be open software, and how it's all going to interact. We have heard there's some next steps and continued ongoing work to be done, but I do believe fundamentally that we are starting to evolve and mature those key elements for enabling optical networks. Open optical networks. And then finally, it is early days. So there are business model challenges to be addressed. There is work ahead of us, and we saw in the survey question, all of you still have many questions that need to be addressed before we can say that we have, everything we need to be able to drive the industry in this direction. So with that, let's move on to some Q&A. Questions and answers. And again, please do feel free to enter any questions you may have into the console. And what I will do is I do have a couple of questions here. I'm going to start with Joe. This goes back a little bit earlier in the webinar. So, I made a specific point that open may include disaggregated. It doesn't have to include disaggregated, but as I look at Fujitsu's portfolio and direction with the evolution of your portfolio, you guys are going down this path. So clearly there's a role, and I'd like to hear from you, why is disaggregated important as we move towards open optical networks?
Great. Well, that's a good one. The goals of being open are flexibility and leading to lower costs and quick time to market. The use of a programmable disaggregated network element makes it easy to interchange parts of the network, components, right down to the optics, pluggable optics. But components such as the transponders, ROTMs, even packet switches can be easily interchanged, and this offers a supply chain flexibility. They offer lower first cost and lower scaling costs, enabling best-of-breed functionality while adhering to the SDN standard for virtual system convergence.
All right, excellent. There's actually quite a few questions on some of the use cases that we've described, and Joe, I'll throw another one at you, and Scott, definitely you can comment as well on this. The question was, with respect to Open Rotom, in addition to AT&T, are there any other Tier 1 service providers who've joined this consortium or are participating?
Well, I could start with that. There are several. They have been announced on the web page for the Open Rotom MSA, so you can see all the vendors that have been, vendors and service providers that have been involved in the Open Rotom MSA, and this is catching on more and more as a way to provide win-win for everyone, the service providers, the vendors, in particular, service providers having these flexible networks that they can deploy very quickly, the vendors to basically get into different parts of the network, where maybe one of their competitors completely had controlled the entire network. They can still get into different pieces of the network, providing best-of-breed functionality. So it's continuing to grow, and you can see different parts of that, again, on the Open Rotom MSA website.
All right, great. A question I'll direct first to Scott. We did in our audience survey, we looked at high performance or the trade-off between high performance and openness. And the question is, what do carriers need to do who have both long haul and metro? Do you have any suggestions or ideas on how this can be managed in an open optical network environment?
I thought that was a really interesting question. I saw when it came in, and I thought it was one that we should certainly talk about. And I think one of the slides in there is actually Joe's slide. I hate to give him credit for it, but where he talked about how, depending on how you turn on different capabilities within openness, you can get better performance. I think for people who have a network that has both metro and long-haul components, the alternative to open is picking one or maybe two vendors which lock you into a specific kind of performance. And you're going to have to deal with and live with what they're able to give you. And if you pick someone who, for example, is very, very good at metro and just has a mediocre long haul, you're stuck with a mediocre long haul. But if you pick, on the other hand, someone who's very, very good at long haul and has a mediocre metro, it doesn't meet all of your needs, you're stuck that way as well. The idea of open optical networking is that we're going to get away from that. What's even more interesting is we may get to a point where you could even have a metro optical network that could reroute over a long-haul network or vice versa by making the equipment more programmable. So right now, your solutions are certainly not going to be any more limited, but in the future, they're going to be even better.
Cool. Joe, do you have any comments on that?
Sure. In fact, through our disaggregated platform approach, the Onefinity disaggregated approach, it surely makes it easy to pick and choose for a service provider to pick and choose different parts of the network for best-of-breed operation. Just as Scott was saying, if they are focused on metro, and typically maybe 60% or more of the service provider networks are focused on metro, and the rest are long-haul applications. They might have different vendors for each of those, but every time you bring another vendor in, it's a big expense to do that. Ideally, it would be great to have one vendor that can do it all, but then you also have risk in putting all your eggs in one basket. Having this disaggregated approach solves a lot of those problems, a lot of those challenges that the service providers are seeing, in that they can have a fully open system, and then if they need to address some additional performance functionality through software licensing, as one example, they can purchase a software license, use the same hardware that they were using before, say for the metro application, but through the purchase of that software license, enable through a software key functionality for greater reach capabilities, using perhaps some proprietary functionality, but still maintaining open interoperability between other vendors. And I went through that, in fact, on the use case of alien wavelengths, where you have one vendor supplying the Rotom, a different vendor, us, we're supplying the transponders. We offered greater performance, but still interoperated with the existing Rotom network.
Cool. Okay, so then Joe, the next question that goes along with that, as we move to open, as we move to multi-vendor, multiple, software, hardware elements within the network, who does the integration? So is that on the service provider, network operator? Is that potentially on the traditional equipment vendors, or is that the integrators? Who takes on that responsibility?
So the easy answer to that question is all of the above. So essentially, the service provider can do it. The third-party integrator can do it, or the vendor themselves can provide that integration. At Fujitsu, we have a services group that include network design, integration, professional services, maintenance, deployment services. They can put the entire system together, not just Fujitsu equipment, but best-of-breed equipment to address the customer's needs, provide that full integration of capabilities, as although we do have openness and we're meeting open standards, there still are some areas where some other vendors may not meet the full line or guidelines of openness and require some level of interoperability before they can go into a production environment.
So if I take that question then back over to Scott, and I'm going to phrase it a little bit differently. So, the other model we described on openness within hardware is that maybe you do have a complete system, but you just want to be able to provide open APIs that enable, again, other systems to manage and direct that hardware. So Scott, from your perspective, does that approach in terms of trying to address this who's going to integrate, or are there other advantages as well you see of the approach that you've taken?
Certainly. Well, there was a really interesting talk by, I don't exactly remember who, I believe it was an analyst last week in Nice at the optical conference. And one of the takeaways from that, which got bounced around a lot, was disaggregation puts the complexity out of the hardware and into the software. And when you've got more and more pieces that you've got to put together, that may not be a good thing. So if you are somebody who has a services group and built into your company and you can do the software, then being able to pick different pieces of Lego and build your own solution is absolutely the right way to go for you. When my son wanted to build his own computer because he wanted the best performance, he picked all the parts and put them together. When my father wanted to buy a computer, he went to somebody and had them put one all together for him completely. It still had all of the openness that we talk about. You can still run over whatever application you want on it, but having it all from the same provider had value. And I think that's what we're seeing with open optical networks in general. Is also, you're going to have some people who absolutely believe disaggregated is the way to go. They want to pick individual Lego pieces and build them themselves. What we've discovered, and most of our providers are not AT&T, the people that we sell to, but people who have to maintain a network on a daily basis with perhaps a limited staff, having a solution which is an open optical solution, but perhaps incorporates Rotom capabilities and maybe OTN capabilities all in the same solution, or transponders and OTN switching, or any pieces of that you can put together. I think there was a nice quote from Verizon at one point saying, "We don't understand how taking them apart and putting different sets of sheet metal around them make them cheaper." So for some people, this idea of openness is terrifying, and by putting some pieces of it together, you take a little bit of that terror away. Now, back to your original question of who's going to be in charge of all of it, that's the big question for all of us, is it going to be an integrator? Is it going to be a solution provider, or is it going to be the network provider? And there are a lot of people out there that want to be the red hat of this world and want to be that integrator to solve that problem, and we'll see how that shakes out over time.
All right, great. I think also one of the fundamental takeaways as we look at this vision for open optical networks is there's going to be many different ways to build it, and it's going to come down to the requirements and the appetites of the individual network operator in terms of what path to proceed down. So I look at, we've actually got a lot of questions that have come in. I think we have time for maybe one, maybe two more questions. I do want to take one more touch with respect to, as we move hardware towards fitting into this concept of open optical networks, something really critical is how that network is modeled. And maybe we get a little bit into the netconf yang or the yang discussion. I'm wondering, Scott, and then maybe Joe, if you guys could each comment a bit on, how do we see the evolution here, where are we at, and what needs to be done?
Well, there's two different parts of network modeling, and I'm not sure exactly what this particular question was about. There's the making sure the optical works part of modeling, and I think that goes back to what Joe did a great job with his slide showing, is if you want to get best performance, you're going to have to use a specific vendor proprietary solution probably and model it their way. But if you're talking about network modeling in general, of how do you put in services and how do you make things work, that's where the whole SDN paradigm gets really interesting, and I wish we had another hour to talk about it, because within things like optical domain controllers and packet domain controllers and path computation elements, that's where all that modeling is going to start happening. The great thing about open optical networks everybody will have the same API working into those, which will make that so much easier. At least that's where we want to go.
Joe, do you have any comments on that?
Yes. In fact, just off of Scott's lead there, that whole SDN control, that really puts it all together. So you may have these disaggregated platforms out there, or maybe not even disaggregated platforms, but you have multiple vendors out there. Integrating all of that, making it work, troubleshooting when there is some type of service impact, that's where it gets a bit scary for the service providers, and that's where the SDN control really plays well. It provides that level of integration, that centralized visibility, the orchestration of the overall network end-to-end, not just one vendor providing one segment, different vendor the other segment, but a complete end-to-end service SLA that can be modeled through the software, changed through the software, and then executed down through the network layers and actual into the production network. This overall will, this SDN control and orchestration management capability, this overall will reduce OpEx and provide a better planning, lower risk for the service provider, and basically simplify operations in general.
Awesome. Thank you. So for the audience, there's a lot of good questions. There was questions around TIP. There was questions around business models, really good, juicy things to discuss. Unfortunately, we're not going to have time today, but I expect that our sponsors and even myself will ensure that we get back to those of you who we didn't answer to engage in that discussion. So thank you to our audience. Thank you to our presenters. I'm going to hand back over to Alan to wrap us up today.
Thank you, Heidi. I want to thank everyone as well for participating on our webinar today and for submitting all of those questions and comments. Heidi, thank you for leading our discussion, as well as Scott and Joe for this truly engaging discussion. So an archived version of this webinar will be made available shortly, so feel free to come back and view this session again or even share it with your colleagues. And just a reminder, you're going to see a short survey pop up after our webinar, so please take a few minutes to fill that out. And make sure you follow us on Twitter for information on future IHS Markit Technology Group webinars. So again, thank you for joining us and have a great rest of your day.